In this video, we're gonna talk about how we name ions. So I already talked about some of the differences between polyatomic ions that you just have to know. We have the parent ions that all end in ATE, and we have the monatomic ions that end with IDE. So let me just summarize that. So the ending of ions, you can have it as ATE, and what this means is it's polyatomic, and it has oxygens in them. And then we have IDE, which means they're a monatomic anion. Okay, we have one more ending, and it's ITE. These are all polyatomic and also have oxygen. Okay. Now, there's a nice pattern here, and I'm gonna do it. I'm gonna set it up first using this series. So I'm going to start off with BrO3 minus, and this one is called bromate. And this pattern always works. It's not the number of oxygens, it's just the relationship with the eights. And so I'm going to show you the pattern, and I'm going to tell you the rule. So there's bromate. I can add an oxygen to it, BrO4, the charge stays the same. I can take away an oxygen, the charge stays the same, and I can take away two oxygens, charge stays the same. Maybe let me just quickly turn one of these red, the parent ion. Let me just make that red, and then I make this guy red. Okay. Now, let's see how we name this now. If we take away an oxygen, okay, then it's going to be, the root is brom, and then what we're going to do is change the ending to ITE, so it's bromite ion. Okay, if we take away two oxygens, now what we do is we're going to add these are the least number of oxygens, so we're going to add a prefix. It's going to be the hypo, and then in one word, brom, and then ite ion. Okay, and if we add an oxygen to the parent ion to make BrO4, then what happens is we add the prefix per, and then you got your root, your stem, brom, and then the ending is still 8, and then ion. Notice when the parent and the one that has more, these are the 8 ions. The one you have less oxygens than your parent, these are ites. Okay, that's always true for any relationship between the 8s and the ites. Let me go and give you the pattern now. Okay, so we have our parent ion. Okay, and it ends with 8. If we add an oxygen to the parent ion, then it's going to become per plus the stem, the root of the name, plus 8 ending. Let me just color it in like I did before. Okay. Now, if you minus one oxygen, then what you're going to have is the root plus, and then instead of 8, it's going to be ite. And I guess I'll just rewrite this just like I do up there. This would be the root plus 8. And if you minus 2 oxygens from the parent ion, then you're going to have a hypo, meaning the least, plus the root, plus the ending is going to be ite. And in all of these, the charge stays the same. Okay, and so memorize this series. You have to know it. The next thing that you're going to have to know is between two species. How about we have NO3 minus and we have NO2 minus. NO3 minus is nitrate, so guess what NO2 minus will be called? Nitrite. Why? Because you have one less oxygen than nitrate. Okay, how about PO4 3 minus, and then we can have PO3 3 minus. Okay, so PO4 3 minus is phosphate, so PO3 3 minus is going to be called phosphite. And of course all of these are ions, ion, ion, and ion. Okay, and so that's the 8-ite rule. It's very easy to remember if you know the ions. The last thing that we're going to name, and this is actually pretty easy, and you can see this, is what happens when we add hydrogens to an ion. So I'm going to use phosphate as example, and just follow by example. That's phosphate. Okay, if I add a hydrogen to it, it'll be HPO4. Now, the charge goes up by 1 because each hydrogen is positive 1 charge, so that becomes hydrogen phosphate ion. Okay, or we can call this the biphosphate ion, because then anytime you just have one hydrogen there, it becomes bi. Now if I put 2 hydrogens on phosphate, it'll be a negatively charged ion, and this will be called dihydrogen phosphate ion, right? Dihydrogen meaning 2 hydrogens on the phosphate. And this pattern works always. You can have sulfate and hydrogen sulfate, but you have to make sure you are an ion. There still has to be a charge left over. If it becomes neutral, then the compound becomes an acid, and we have a completely different set of rules for that. So I have a nomenclature cheat sheet that I'm gonna put in the webpage. Download it. It has a summary of these rules. Start practicing and start making sure you understand how this works.